This is Chapter 3 review quiz. I'm going to go through the solutions that will cover each question in preparing us for Chapter 3 test. The lifetime of a 2-volt non-rechargeable battery is in constant use has a normal distribution with a mean of, so here's mu, of 516. Standard deviation is 20. The proportion of batteries with lifetime exceeding, very important word there, 520 hours is approximately what? So again, very good practice to make a normal curve where this is the mu, 516, and they wanted to know how many exceed 520. So the graph is important for us to know what area we're trying to look at. Now, we're going to need to find a z-score for this. So our formula for a z-score is x minus mu over sigma. So in this case, 520 minus the mean, 516, divided by standard deviation, and that will give us 0.2. A z-score of 0.2 on a z-table would be right here. That would be 0.5793. 0.5793. Now this would be fine if we wanted the amount or proportion less than 520, but we want exceeding. So we would take 1 minus that value to get the area to the right, which would then be 0.4207, or C. Number 2, the most common intelligent quotient scale is normally distributed with a mean of 100. Again, drawing it out is very helpful. Many school districts across the country need to identify gifted and talented. Typically, these children have an IQ scores in the top 5%. What's a minimum score that they can get in? Well, if they're in the top 5%, they want these people where this is 5%, which means this is 95%. So we need to look on the Z table to find 95%. 95%, so 0.95. Here's 0.959, 0.9505, 0.9495. We could choose, they're both exactly the same, so we can choose either one of these. We'll see what gets us closest. Let's use this one, which would give us 1.6. Four. 1.64. Okay, now we're going to use the other equation, which is x equals mu plus z sigma. We have a mean of 100, a standard deviation, or a z-score, excuse me, of 1.64 times standard deviation, which is 15. And that will give us 124.6, which is very close to this one. Had we used the other value on the table, we would have been about 0.15 different, so not much different. An instructor at a large lecture class found at the end of the semester that total points scored by students in his class were approximately normal, with mean of 530, standard deviation 80. But what percent scored between? Okay, so we're going to look at 490, which is over here somewhere, and 590, which is over here somewhere. And we want between. So we need to find the z-score for each one. So let's find the z-score for the lower one. So we'll say B for below. That is, well, it doesn't matter what letter we use, but that'd be 490. I'm going to change this, pardon me, so I can make my next step a little bit easier and less space. Let's do the 590 minus the average. Then we'll find the other one, which is 490. And our results would be, for the 590, it would be 0.75. And for the 490, it would be negative 0.5. Again, our z-table would tell us that 0.75 would be 0.7734, and negative 0.5 would be 0.3085. And we are going to subtract those two because we want the difference. So here is 0.7734 is all over here. And the 0.3085 is down here. So we're going to subtract the two and we will get the area in between. And just to clarify, how did I get that? Well, 0.75 z table would take me right here. 0.7 going inward. 0.75 would be this row down. That's the second decimal place. And they would meet right here, and that's how we find the 0.7734. Which is what we had here. When we subtract those two values, we will get 0.4649. And that is our solution. So if you make it a percent, we're looking at A. Number 4, too much cholesterol in the blood increases the risk of heart disease. Now they tell us some information about women, which is our mu and our standard deviation, and they tell us some about, so with this information, then we have to decide about what percent of young women in this age group will have cholesterol levels less than 150. Okay, so we have, again, a situation where we need to find a z-score. Again, I should make the graph first. Here's 185, and you have 150. So less than means we're looking at this area. So 150 minus 185 divided by standard deviation, which is 39. That calculation would give us negative 0.8974. which is approximately negative 0.9. Our C table only goes to 2 decimal places, so this will be good. 0.9, negative 0.9 is right here, which is 0.1841, 0.1841, which is about 18% B. Last question, too much cholesterol thickens the heart, or increases the risk of heart disease. Now let's take a look at women, which we already said we have. We're going to look at men, which has this mean and standard deviation, and they want to compare the two. Sandy has blood cholesterol of 220, and her father has 250. Well, who has the higher cholesterol? Well, they have different standard deviations and mu and means, so we have to do a z-score for each one. So let's do Sandy, and Sandy's z would be hers, which is 220, minus the women's mean divided by the women's standard deviation, and that would give you 0.8974. The men's, or her father, oops, sorry about that. Her father would be 250 minus the men's average divided by the men's standard deviation. That would give you 0.7794 or 0.77. Now what does that tell us? It tells us that the women is further up the bell curve. The women's score here is further up from the norm. It's up here. And the man's is closer to the norm. Not by much, but a little bit closer. So in terms of who has the relatively higher cholesterol, it would be hers. So Sandy. This ends the practice quiz for Chapter 3. Hope it was helpful, and I'll take questions tomorrow if you have any.